Hello students, we are going to start with a new chapter, that is the first chapter, real numbers. The weightage of this chapter is 6 marks, okay. This chapter is little theoretical basis and it is really scoring, okay, provided you understand, correct. So before we start with real numbers, let's have a quick recap. We have started our journey of numbers with natural numbers, which you have learned from the lower classes, which is also called as counting numbers. It starts from 1, 2, 3 and so on. Then when you add 0 to the natural number, we get a set of whole numbers. So whole numbers, that is remember W, 0, 1, 2, 3, so on, that is whole numbers. Next we have integers. Integer means number line, right? The right side all the positive number and 0 and negative. This positive set of number is called positive integers. These are negative integers and 0 is neither positive nor negative. So in short we can say natural, whole and integers are the numbers without decimal. It is quick to remember or memorize, understand, correct? Without decimal numbers here. Next in standard 7th, 8th, 9th you got introduced with a special set of number, that is rational numbers, right? So in this rational numbers we know it is written in the form of P upon Q. P by Q, where P and Q are integers and Q not equal to 0. Right? We also learn the relation of these integers. Like can say all integers are rational numbers. Right? Because we say P upon Q, 2 is an integer which also can be written as 2 upon 1. So any number can be written as upon 1. So all integers are also rational numbers. So till 9th standard we know that rational numbers, so indirectly all the set of numbers come inside the rational numbers. Okay, so all natural numbers are rational, the whole numbers are rational, integers are rational, right? So integers is a set of all natural and whole, and all integers are rational numbers. Correct? P upon Q. In the 9th we specifically understood the definition for rational numbers in the decimal form, that it is rational numbers can be said terminating in the decimal form if it is terminating, or it is non-terminating recurring, then we say also to be a rational number, right? So terminating means the division is complete, that means the remainder is 0. If it goes on and if your quotient is in the form of non-terminating recurring, like for example 2.323232, we put a bar, remember? So that is non-terminating, it is not terminating and but it is recurring. So either it is terminating or non-terminating recurring, that is rational. Irrational numbers which cannot be expressed in the form of P upon Q. Next set of numbers, irrational, you have got introduced with 9th standard, in 9th standard, that which cannot be expressed in the form of P upon Q. You came to know root 2, root 3, root 5, how to locate that specifically in the number line. So basically in the number line we have learned how to plot rational numbers, how to plot irrational numbers, correct? So in the irrational numbers which cannot be expressed in the form of P upon Q, or the decimal form we can say, if it is non-terminating and non-recurring, then also it is said to be irrational numbers. So this is the journey what we have covered till 9th standard. Now in the 10th standard we know that real numbers you are going to learn. So real numbers is the biggest set of numbers which has both rational and irrational numbers. So it is all rational numbers are real numbers. All irrational numbers are real numbers, but all real numbers are not rational numbers, because real number is made up of rational and irrational, correct? So all real numbers means all rational numbers are real numbers, all irrational numbers are real numbers. It is the biggest set of numbers which consists of rational and irrational. When you go in 11th standard, you will learn about complex numbers. So journey continues, correct? The journey is continuing. So in this chapter what you are going to learn, there are 4 exercises, and in this 4 exercise, in the first 2 exercise we are going to learn properties of integers. Second and third deals with rational and irrational number. Okay, so let's first stick to properties of integers, the first and second exercise. First exercise deals with the division of integer. Second exercise deals with the multiplication of integer property. So let's first deal with the first exercise, that is division of integers. So for that, let's take an example and explain that you have already learned in the lower classes. You have learned about the division. We are just going to formulate and give a name. That's it. Let's take example that I take two numbers 23 and 6. Here 23 is bigger and 6 is smaller, right? So here this I consider this is dividend and 6 as the divisor. So I am dividing this 23 by 6. So I get 6 3s are 18. So here 3, 18. So 23 minus 18 will give you 5. We all know the relation, the terms that is involved. So 23 is a dividend, 3 is a quotient, 6 is your divisor, and your remainder is 5. Correct? And we put this beautifully in one relation. That relation we all know, that is dividend equals to divisor into quotient plus remainder. This you have learned in the second chapter of polynomials. Also we have done division algorithm, right? Now after second we are doing the first chapter, right? So you know that division algorithm is in dividend equals to divisor into quotient plus remainder. Now this we will just give us symbols. Now here dividend, let's take dividend, that is here in this case A is 23. Sorry, I will denote this dividend by A and divisor by B. This symbols are the textual, right? So you have to follow the same. So here A dividend is A, my divisor is B, quotient we will take as Q, and this is R. So this is something which you have to remember, that is this relation A equal to BQ plus R. This relation is called as Euclid's division lemma. This is the first thing, first property, that is Euclid's division lemma. This lemma is nothing but a proven statement which we accepted, like you learned in 9th standard about axiom, correct? So A equal to BQ plus R. Now dividend equals to divisor into quotient plus remainder. So A will be always a greater number between the two number, right? So how does Euclid's division lemma definition goes then? It goes like, given two positive integers. So if there are two positive integers, okay, that is A and B, where A is greater than B, then you can find unique positive integers Q and R. Here everything A, B, Q, R is positive integers. So it's hold for a positive integers. So given two positive integers A and B, A greater than B, then A will be equal to, then if A and B are two positive integers, A greater than B, then you will find unique integers Q and R. You will get Q and R such that A equal to BQ plus R. Now when we know that when we divide it, okay, when we divide it, when we say that division is complete, when the remainder is 0. If the remainder is not 0, we continue the division till the remainder is less than the divisor, correct? Okay, if the remainder is if less than the divisor, then we cannot do the further division. So here that quality, this particular condition we will present in the form of inequality, which is very important, that we continue the division, that our remainder, that is R, if it is equal to 0, we say it is completed. So here 0 less than equal to R, this means R is greater or equal to 0. So if R is 0, division is complete. Or if R is greater than 0, we continue the divisions till R is less than the divisor. R is less than the divisor, right? So this is very important. Here the important heroes are R and B, where we go the division and find, right? Here the important role is played by R and B. Okay, let's first see. So this is Euclid's division lemma, which you already learned, but given in a special format name, that is Euclid's division lemma. A equal to BQ plus R. So given two positive integers A and B, there exists unique integers Q and R, such that A equal to BQ plus R, 0 less than equal to R less than B. Now using this lemma, we are going to find, that is we are going to use Euclid's division algorithm and find HCF. Now Euclid's division algorithm, now this algorithm word is very familiar to you because you have learned in the computer. Algorithm is nothing but well-defined steps to solve a sum. So usually this algorithm, Euclid's division algorithm, is using lemma, that is proven fact, to solve and find HCF. Simple, correct? So we are going to use Euclid's division lemma to find HCF, right? So here the question will be, use Euclid's division algorithm to find the HCF. So basically the first property we are going to learn division property to find the HCF. Now we are going to, when two numbers are given, we are going to find HCF. We will be using this fact and we will be writing in the form of A equal to BQ plus R till this r is 0. We will get r0 means we have to continue the step. I'll show you one example, but I'm just telling you, please understand that if remainder is 0, the step where you get remainder 0, then this b becomes a HCF. Then b becomes a HCF. So if you have, Euclid's division algorithm basically says that if you have two positive integers a and b, and you are taking that a greater than b, you will write in the form of a equal to bq plus r. That is lemma only we are using. 0 less than equal to r less than b. If you get r as 0, if you get remainder as 0, then b is HCF of a and b. B is the HCF of a and b. B is a divisor. B is a divisor. Correct? I hope you understood. For example, I take 20 and the divisor is 5. So, if I want to find 20 and 5 the HCF, so 20 can be written as 20 equals to 5 into 4 plus 0, we know that. So, what is the divisor here? 5. So, 5 is the HCF. In the first step only we can write. So 20 and 5 we want to find the HCF. So you know that 20 can be written as 5, 4s are 20 plus 4. So I have written in the form of A equal to B into Q plus R. So here my R is 0. So what is the HCF here? The divisor, that is 5. Right? Let's take other example how to solve the stepwise. I'll take one example so that you understand. So let's take an example. Use Euclid's division algorithm to find the HCF of 237 and 81. Let's take this example. Okay. So I'm going to use this lemma and do this Euclid's division algorithm. So let's divide first. This division, I'll say you have to do it. If you do it, then there is chances of doing mistake will be less. Okay, but it is not that compulsory. Writing this form is compulsory. So I divided by 81. So 81 ones are 81, 81 twos are is 162. So 81 threes are will give you 243. Okay, so twos are. So here I take 2 and I get 162. Correct? So when you divide we get 5. So 13. So here 75. So you have got the step that 237. 81, I will write the step 1, that is here, let A equal to 237 and B equals to 81. So I am using Euclid's division algorithm. So first step is 237 is written as A, this B is divisor, into quotient. My quotient is 2 and my remainder is 75. I hope the first step is clear for you. Right? Now second step, I have to continue the division. What is my aim? I have to continue the division till my remainder becomes 0. Correct? My second step, this important, that R and B, I said they are playing a very important role. This remainder will become the divisor and the divisor will become the dividend. So here I am dividing now 75, here 81 by 75. So here the step. Did you understand? So we are going to get the second step. What is this divisor? Is the remainder is becoming the divisor and the divisor is becoming the dividend, right? Now 75 when I divide 75 twos is 150, 75 ones are 75. So here we get 6, correct? So the second step here, my divisor is becoming the dividend. And my remainder is my divisor. So 75 ones are 75, this is 6. Right? Now no need of division. If you are very thorough, you need not do it, right? And do the next step also. Now here 6 is my remainder which becomes a divisor. Okay? And this divisor becomes a dividend. Again I repeat, this divisor becomes a dividend and this remainder becomes a divisor. So 75. Let's divide 6 ones are 6, so 5 here, 6 twos are 12, so here I am getting 3, right? So here the remainder is less than the divisor, correct? Now here again we have to continue this step. So again now I will write in the form of this lemma, that 75 equals to, my divisor is 6 into 12 plus, so 6 into 12 is 72 plus 3 75. Correct? I think next division no need to do. So 6 is your divisor, becomes a dividend, and this remainder becomes a divisor. So 3 2s are 6 plus 0. So here we have continued the step till r is not 0, not 0, not 0, and finally we got r is 0. So here we'll write, since r is equal to 0, therefore our hero or the answer is the divisor. So here, since r is 0, therefore HCF of 237, no need to write if you just put a bracket. So HCF of 237 comma 81 is 3. So since r is 0, B means your divisor. So the divisor is your HCF. So directly you can write, since r is 0, so HCF of 237 81 is 3. Right? I hope you have understood this Euclid's division algorithm. This is already we have learned. Okay, a quick recap I'll do. So lemma you have already learned. This new thing what you have learned, that is a equal to bq plus r. This is the terminal. A is a dividend, b is a divisor, q is a quotient. So using this lemma we are doing algorithm. So algorithm is well defined step. So we are using the lemma and we are solving. Actually lemma and algorithm are very closely interlinked. Sometimes we find it very difficult. They are using one another, right? So Euclid's division algorithm is basically to find HCF and we are using the lemma. So here this condition 0 less than equal to r less than b, right? So here the important rule we know that whenever we do a division, remainder is either equal to 0, then the division is complete, or if the remainder is less than the divisor, then we stop the division. Correct? So this condition we will do till this lemma we will use it to solve this algorithm till you get r is 0. The step where you get r is 0, then b, that is a divisor, will become the HCF. So in this 237 81 I have divided. So as I divide the first step I have written. So 237 equal to 81 into 2 plus 75. So 81 is a divisor. This is a quotient. Then again 81 becomes a dividend. Remainder becomes a divisor, and you get so on till this r is 0. As r is 0, you have to look out for the divisor. Students find it sometimes do usually mistake by taking 2 or 3. So here you remember the divisor is the HCF. So I want you to try exercise 1.1. The first sum, use Euclid's division algorithm to find the HCF. I hope you have understood this very thoroughly. So please try it out and check it out. I'll send you the notes. Bye. Thank you.